The following content has been provided by RWTH Aachen University.
Okay. Good morning, everybody. Welcome to Designing Interactive Systems 1. Today, we're going to start a separate section, the next section sort of this class. And before we do, just a couple of comments. First of all, as Marcel and Ollie already communicated, we weren't exactly happy how the midterm worked in this like massive online format. So we'll figure out what we can do about this. So rest assured that I'm sure we'll find an option in which we can address your concerns and figure out how best to calculate or turn this exam into something that nobody will feel disadvantaged about. It'll take a bit of time because we need to go through the Prüfungsausschuss, the examination board. So we should probably be all set. They meet again in a week or two, and then we should know exactly what we can do. Also in Moodle, we're still seeing a fair bunch of incomplete groups for the project. So please do use the forum, get in contact with other folks, and make sure that you have a group set up and that you can get started working on the project as soon as possible. This is sort of the big thing that's happening the next couple weeks and months even, where we move from the individual assignments that are really separate and each week about a new and different topic. We're moving to the project, which really builds week by week, builds on everything. So if you miss the first one or have very little time to do the first one, you're gonna have to struggle to catch up and build in your following weeks, build on top of your results. All right, with that out of the way, a quick review on what we talked about last week. I know you've all done plenty of reviews, obviously, for the midterm, but still, I just wanted to briefly touch on these different things here. So first of all, anybody remember the different phases of the technology life cycle? It should come fairly easy now that you've just studied for that. Yeah, Frederick, go ahead.
Okay, so I think I'm always a little fuzzy with the name, but I think the first one was the Enthusiast Face. Mm-hmm. Then the professional, which is basically the phase in which the technology is possible. You can hack a solution together, but it doesn't really work for anyone other than the person who built it themselves, and mostly doesn't even work for them. So it can easily break, for example. Then there's the professional phase. In this phase, the technology has become stable enough to be used in a work environment and can accelerate the work. But consumers couldn't use that in that time because it's still not easy to use or easy enough to use. So you have to have some special knowledge about how it works or teaching. And then there comes the consumer phase, in which the users actually can use it because it's easy to use. And at that point, somewhere happens the sweet spot in which it's, well, basically perfect for that arch of technology, you can say. And after that, there's nothing better to add other than additional functionality, which you wouldn't need. So then there's the Baroque phase, which basically makes the technology more complicated and maybe also harder to use.
Mm-hmm. Exactly. Thank you. Great summary. And of course, it's not a set in stone model. Not everything advances according to that pace. But also notice we're talking about technology, right? Not a product. A product is typically aimed at, like, the iPhone, right? That was aimed at the general consumer market. It was not aimed at just professionals. So we don't go through these phases with a single product, but more with a technology, a product class, a device class, or something that got introduced in that way. Great. And then we had a look at a couple of those visions of the past to see what people were expecting, just a few years or a decade or so down the line. And we saw some key advances there that were being expected or predicted in these videos. for put that there, what was the key new thing that put that there was suggesting? Yeah, Shailis.
So they were able to combine different modalities, like they were able to combine haptic input with voice, and they were also the computer was also able to recognize very vague commands or voice commands, essentially.
Mm-hmm. Exactly, the voice and gesture streamed together into a multimodal form of input was a tricky one. And then we saw the Apple Knowledge Navigator. Maybe a few of the things that this was trying to get people excited about.
So it had a very, very advanced AI, kind of butler for a person or personal assistant that was able to organize their week, etc. And it was able to hold perfect human conversations. And yeah, and it was even able to conduct research and then help the user out with what they were trying to do. So
yes, exactly. And was all sorts of networked collaboration going on. But the key thing was really this assistant that was following along what was going on and made some pretty smart remarks and fulfilled some tasks based on a lot of understanding of the situation. And the Starfire video that we saw then, what were the key things in there that were suggested as new forms of interaction?
in gestures, touch, and also they were able to do all sorts of photo, video, and document editing. And the main key thing with the Starfire was that they were trying to aim for realism, and they were trying to aim for technology that will exist 10 years into the future. And yeah, and
yep, that's correct. And I think the that's an interesting one, right? This limited time frame as saying, like, I don't want to fantasize like, you know, Star Trek, but I want to really come up with things that I know are already in the labs around the world today and that we can reasonably expect to become available within a 10-year time frame. So it was a little less futuristic than, for example, the Knowledge Navigator, which took a very different approach in that sense. Okay, and then there were a couple, of course, lessons to be learned that the Starfire video team around Bruce Tognazini drew out of making that thing that are still true today, which is, you know, these things about video prototyping, where we shouldn't risk inventing things that are unlikely. You need to iterate around the video prototype like any other prototype. And what that means, we'll actually learn today, this iteration over prototypes. And also including things that can go wrong, right? Making mistakes part of the story, because as you know from the Norman books, mistakes are a big part of what just happens everyday life when we interact with our environment. Okay, and then we took a look at the Ubicom. Thank you for testing your video, Mike. The Ubicom device classes. So what were those device classes? Anybody like to tell us what we saw there? This was the Park video about ubiquitous computing. There were different devices introduced. All right, that shouldn't be too hard. Ziyong, what do you think?
We had a tab. We had some handheld thing that was like a pager, but I don't remember the exact name for it. And we also had like a wall, like a board.
Right.
Yeah.
And I think what you meant by tab was probably the pad. The names are confusing. I know they all sound the same.
Okay. Yeah.
tablet, and it's very confusing. So yeah, these three different kind of classes, right? Inch, foot, yard was their very simple, mnemonic to remember these by. Highly connected, of course, and really sort of always connected. And this was very ingeniously faked by the team. If they wanted to suggest you would have something like what we now call an iPad in your lap, and it's always on and it's always connected, they just used the screen and tethered it with a big fat cable, right, to provide constant connectivity to it. All right, I think then we can move on to our roadmap here. So this is where we are today and where we're going next, right? We've covered the human in our first part of the class. We have then looked at the computer, if you like, the history of HCI and HCI visions and these phases of technology. And we're now at the point where we enter the third column here of this class, which is the development process, right? This will, after we've laid sort of the theoretical foundation with the first column and given you a historical context with the second one, we're now going to go into the tools of the trade. How do you actually create interfaces and that work well? And I often like to think of the when I'm called into coaching or consulting and usability for a project where people are designing software and they want input on the interface, I like to think of it as a two-stage process, like the two things that we can do. There are, I would say, about 30% of the bugs in the interface you can fix with just what you learned in column one, right? Providing feedback. That's always true, right? These things always need to happen. So you don't really need to know too much about the concrete project to know that providing feedback is a good idea. There are very, very few situations in which providing feedback is not what you want to do. So you could say about 30% of the interface quality you can derive from these general rules that are based in human psychology and that nobody can escape, no matter what kind of user they are, what kind of situation they're in, and what kind of task they're trying to do. But the bigger part, the significantly bigger part of getting the user interface right, sort of the second stage of this rocket that we're trying to launch here, the second stage is really, it needs to know what the task is, who the user is, what context they're working in. And then we can't provide universal answers as to provide more feedback. In this case, we need to really understand what they're doing and then figure out the right answers to the interface design questions that we have. So I can't give you golden, always true guidelines for the second part, but I can give you a process to arrive at these answers. Right? I don't have universal answers, but I have a process to find the answers. And that's what we're doing in this third column of the class. Okay, so without further ado, number one, number two, check. Diving into number three. First of all, when software started to get developed around like the 40s, 50s, when computers became available, a model was derived that was pretty much based on engineering, civic engineering, how you would build like a bridge or something like that. And this model was called the Waterfall Model. And I'm sure you've heard about this in software lectures in some kind, no matter where you did your undergrad so far. And this model assumed that you would do an analysis phase in which you figured out the requirements that you had as a milestone. And then you would basically enter a design phase in which you decided to do what the general scope of the software was going to be, what kind of features it would have. You'd have a list of features, and then you would enter, you make a software architecture, you would create this, you would implement it down, usually top down, create the routines that you need, and then you would test the whole thing and see whether it did what it was supposed to be doing based on your requirements. And if everything worked out fine, then you went into maintenance. So this is how you would build a bridge. And in the early days of writing software was considered an art, right? It wasn't really considered an engineering task very much. I mean, there's this wonderful series of books by Don Knuth, who I'm sure you all know, one of the fathers of modern computer science. And he wrote this wonderful series of volumes called The Art of Programming, right? In which he explains, the beauty of certain algorithms, and he explains how do you sort and how do you navigate a linked data structure, and so on and so on and so on. And yes, there's a lot of that has a sense of an art to it, but people quickly discovered in the 50s that writing code, as soon as it went beyond a page or two, needed a model for development, very much like building a bridge. And so they adopted what was out there, and that was the waterfall model. Now, this is better than having no model, of course, but it has a bunch of issues. And the first issue with this model is that the phases here are quite idealistic. The reality of software development quickly discovered that you needed to do a lot of backtracking. You needed to often go back to, after you did your implementation, you discovered you'd forgotten some key features, or the testing showed you that, okay, the way we did this, it's just not performant enough, or the users aren't getting out of it what we need. So you needed to go back and re-implement, or maybe re-architect and redesign. So there was a lot of, going back up this waterfall, like a salmon sort of, and that's expensive, right, to do. This was not just because plans change. So, you might say there's maybe something that you might say, I implemented the way that I did, according to my design, but I made a mistake. I didn't quite match my design. And that's one case to backtrack, but sometimes also just reality changed, right? Imagine writing a software for a business where a lot of people are traveling out and about, and you're halfway done with it. And then, the iPhone happens, right, in 2007. And all of a sudden, everybody wants to have a smartphone and wants to use the software on the smartphone. So your reality has just changed, right? And that means that you need to adjust your plans. Also, the scenarios of use that people used to feed requirements into this model were often very abstract. They assumed sort of an idealistic, perfect user that wouldn't make any mistakes, for example, like we know now people do all the time, and that wouldn't have any limitations in terms of like attention, for example, and those assumptions were just not right. And if you made any assumptions in this model that it would actually take until the testing phase when you would discover that your assumptions might have been wrong. And to fix it then meant that you had to go all the way back and basically reanalyze, redesign, re-implement. And that's really expensive because you're throwing away code. And writing code, as you all know, is a time-intensive task, and it's expensive because people who are doing it are smart and cost a lot of money. So we know better than that. And we've known for a long time that this model doesn't work, especially not as software gets more and more interactive and gets more and more woven into the tasks that people are doing in their daily lives. You might get by with this model when you're writing a mainframe application where there's an operator that sits down at that mainframe in the morning at 8 a.m. every day and does certain data entry tasks, and then you have to process that data and get it back. That's pretty well scoped and pretty clear cut, and the user is just basically submitting themselves to however the technology works. And that was the case of how things were designed in the beginning, because computers were super expensive and human labor was cheap by comparison. But today, this is not the case at all. Right now, today we need to make people effective and productive with the software, and the cost of a computer is nothing compared to the cost of the person who is using it, at least not in our high-wage countries like Germany, for example. And so we know better, and we have known better for a long time. Pretty much, you can read this, and you did see this, right? Even the STAR video, the STAR prototyping project, right? The the Xerox PARC STAR project that redesigned the Alto, already talked about how they talked to users, did interviews, observed people, involved users in the design, involved graphic designers in the design, involved psychologists in the design of the software and its interfaces to really nail it and to really support the task of the user in an ideal way. So it's really a role change here that happened as soon as computers became so cheap that they're not the defining factor of the cost of usage. There's this wonderful term of total cost of ownership that I'm sure you've heard, which means I can buy, if I buy Ollie a new MacBook, you could say, okay, the cost of that new computer is whatever, 3,000 euros. But that's not really the cost, right? The cost is these 3,000 euros, and any minute that Ollie will spend needlessly configuring or recovering from errors that the system introduces, or just struggling with a bad user interface, all that is adding to the cost of having that machine, right? So that's why total cost of ownership is such an important concept in this sense. So what we're going to see now is a better way to do this software design, especially in this modern world of software that usually has to support people in their tasks, that is highly interactive. And that is what I call the DIA cycle. You're going to see a whole bunch of different names for this. Task artifact cycle, human-centered computing cycle, or human-centered design, or whatnot, iterative development, even agile is sort of closely related to this. But I call it the DIA cycle because it has three essential phases that I think are important to distinguish. There's a design phase, there's an implementation phase, and there's an analyze phase. In the design phase, you collect the ideas of how you want to improve your current concept of the system, your prototype maybe. In the implementation phase, you actually build that vision. And then in the analyze phase, you analyze whether it works or not, typically with users. Not always, but most of the time. So analyze phase, you're evaluating your interface, and it could also be called the evaluation phase, but then it would be the DIE or DIE cycle, and that just didn't seem like a very good abbreviation for me. Also, warning, implement. I know that all of you that with a computing background are going at implement. Oh, that means I sit down and code. No, implement means building and creating some artifact that helps you to analyze your design. And that artifact could just as well be a paper sketch you created with a pencil on a piece of paper within 10 minutes. Or it could be an advanced software prototype that you created with Adobe XD or something like this, or anything in between, right? So only towards the very end, this is actually working, functional, fully implemented code. In the beginning, the implement phase doesn't actually implement software code as much as it implements physical or some kind of other paper prototypes. Now, it's called a cycle because we're not only doing this once. We usually need to do this in several iterations. And you could say that in a way, one iteration of the DIA cycle is kind of like the waterfall model, right? We take the waterfall model, we run down the waterfall, and when we get to the end where we test, we basically know that we're going to start at the beginning again. Now, obviously, that means that not every iteration of the DIA cycle can take 9 months, as you might with the waterfall model, where the whole project takes 9 months, but they have to happen in days, weeks, this kind of level. And with each iteration, you don't ask the same questions and you don't try to improve the same things. Hopefully, your design becomes obviously more concrete, more precise, and it also becomes, the analysis and the user feedback you're collecting should be focusing on smaller and smaller issues and problems, right? So you want to get the big questions and the big issues out of the way first. Similarly, your implementation gets more detailed and more technically complex as we go. The prototype, right? In the beginning, it's just maybe a paper sketch, and in the end, it's actually working code. So the idea here is you want to fail early, you want to fail phenomenally and big early in the project when you haven't spent a lot of money and time with your team invested into building stuff and really coding. And you want to get the big questions solved and the big mistakes made early on so that you are then on the right track and then make smaller and smaller mistakes as you go. I sometimes like to think about this, again, to use another space metaphor. If this is a rocket and you're shooting for the moon, in the beginning, you want to get the very rough trajectory, right? You need to be aiming very roughly towards the moon, right? So you make big course corrections in the beginning. And it's not important that you nail it by 0.1 of a degree, but you want to be roughly in the right direction. And then as you get closer, your corrections need to become smaller and smaller to really hit that spot, right? You cannot make a major course correction at the very end. It's going to be hugely expensive and you might miss your mark. So that's the idea of the DIA cycle in another space metaphor here. And we're not just dreaming this up, by the way, right? It's not just a bunch of HDI folks with black turtlenecks that thought this is a good idea. This is actually an industry standard. This is an ISO standard. So the International Standards Organization, ISO in German or ISO, has a standard. It's 9214/210, something like that, is a user-centered design standard. So this stuff has really made it into industry and is accepted as the way to go. Let me take the cycle and unravel it. Like I said, every iteration is a bit like doing a waterfall model iteration. So what that means is that in the beginning and at the project start, your design phase might consist of brainstorming different fundamental representations of the issue that you're doing. And you might choose a certain way to represent it. You could think, are we even thinking about making an app here for this problem that we're facing, or are we making a website, or are we making a device? What is it? And we rough out the style of the interface. And this can be done with low fidelity paper prototypes. Don't worry about if you don't know all these terms yet. We'll get to each of these later on in these classes. And once that has happened, then you need an analysis, of course. And you might do a walkthrough focusing on the task that the user is supposed to do with your system. And then you redesign it, right? And that gets you into fine-tuning your interface. And then, maybe if it's a screen-based interface, really finally design every single screen, do a heuristic evaluation, which is based on some golden rules of interface design and just checks whether you're not making any major mistakes here. Often these rules are based on the natural psychological base things that you already know from our earlier classes. And then you have what we call medium fidelity prototypes that are a little more powerful. They're a little more functional. They're not just a piece of paper. They might be running maybe a bunch of Photoshop layers that you're clicking in between, or a PowerPoint that looks like an interface and you can click on things and stuff seems to work in the interface, although there still isn't any working code behind it. And then we get to real usability testing and of course, again, redesign again with high fidelity prototypes that are built to closely mimic the final system already, right? So this could be built in the actual coding language, maybe even, or it could be created in an advanced prototyping tool like Adobe XD or Figma or something like this. And then ultimately it rolls out to the things that you might already know, because that's often what we see as consumers and as users of software in field testing and alpha and beta tests, right? So if Apple decides to release their next operating system as a beta, as a public beta, this is at the very, very, very end of this whole process here, where you basically have a working system and you're just trying to see, you're basically thinking this should be it now. I don't think we have any bugs anymore that I know of, but I'm sure we still have some that I don't know of, so you're trying to discover those. We also tend to have more and more users in terms of the numbers involved towards the end. Why? Well, because if you make a major mistake in your design, you only need 1 or 2 or 3 users from the domain trying out your interface idea to tell you that you're wrong. Right? That's enough. You'll find those big mistakes very quickly because they can't hide. But the fine things where you know maybe in a special situation your interface or your system doesn't do what it's supposed to do, that needs more and more people, just so that statistically you're covering more and more ground of what your system is supposed to do. But we're not only going to tell you about the DIA cycle, you're going to experience it yourself. And this is why we have the project. One of the reasons we do the project in this final section of the class is we want you to experience at least a little bit what it's like to go through these iterations. So we will have some milestones along the project here for things like brainstorming, storyboarding, prototyping, observing users, and testing with these users. And these things, the results from these tests and observations will then feed back into your design of your particular system that you decide to build this semester. A real commercial, full-blown industrial piece of software would require many more iterations of this. So we're cutting this short, and it may feel weird to you that we are actually not strongly aiming for a fully functioning piece of software at the end of the semester. You're going to be writing code everywhere in this computer science degree that you've signed up for. So we don't want to focus on it because we know you get a lot of exposure to that. We want to focus on the early stages that are going to be unfamiliar to you, that you haven't done before. By the way, the topic of the project, we don't give you an exact thing like build the following application with the following 5 screens, because that would miss the point, right? We want you to find out what the application is that you need to design. So in that, instead, what we give you is a rough topic, and we want you to build interesting and useful tools in that topic. And this year's project topic is going to be getting familiar with new places. These new places that we mean are going to be outdoorsy places because of Corona, right? So we don't, you will have to study and observe people doing things. And if you need to get even reasonably close to them, right now we can only really do that outside. So the idea behind this is that we're going to try to make you more of a designer in addition to being a great engineer. And if I had to describe in one word what differentiates designers from engineers, I would say engineers know how to fix problems, and they're good at finding solutions to problems. And designers are good at finding problems, and they're good at finding out what problems to fix. So that's why you have to find out for yourself, what is a good and useful tool for a particular user base, a target user group, and a particular task that you can choose. What is it that really would make their lives easier in this particular situation? Even Norman added in his 2012 second edition that you guys are looking at, added this DIA cycle to his book, which I found really satisfying to see because it wasn't in the original one. But he called it the human-centered design process. And as I said, it's just another name for the same idea. And in his case, it includes, idea generation, prototyping, and he divides the analysis phase into testing and observation. This is very similar to what we have, right? We say analysis is sometimes observing people, sometimes testing with prototypes, and he has two separate structures there. But it's the same philosophy, right? We put the user at the center of our design process. And even human-centered design is this process here, this wheel is basically a part of a broader concept that is called design thinking. And we'll talk about that very briefly later on. As Don Norman puts it, one of my rules in consulting is simple. I never solve the problem I'm asked to solve. What does that mean? I said before that designers are good at finding problems, right? Where engineers are good at finding solutions. And so the idea here is that oftentimes you might get called in and be told, this is the kind of software that we need because we know. And as a good, designer, you would be able to also go in and say, let me see if you actually got that right. To give you an example, Marcelo, or other PhD student supporting this class, just had, is working with the university central administration to help them design the software that we are using at the university in teaching and in research and in budgeting and all that kind of stuff. And in one project, the administration was very sure that they knew exactly what kind of software they needed. And he found that they'd forgotten about an important stakeholder, important part of that process, a whole group of people who would have to use that software and who would be impacted by its use. And so they were solving a problem, but they were solving the wrong problem. And with our processes and methods, we were able to uncover that mistake, address it, and it wasn't that hard to fix, but you need to find out about it first. And this process, in the extreme case, is called root cause analysis. The root cause of something is the original underlying reason why something, why there is a problem. And since people often rush to solving a given problem without questioning if it's even the right one to solve, especially engineers, in the real world, we need to discover these problems. In the real world, if you go out there, these problems are not written in big letters onto the wall. You need to find out about them. And we rush into this, and instead of doing that, the better process is to find the right problem and then find the right solution to it. Right? That's what the root cause analysis means. So you could say, this is where you enter, Sherlock mode, right? You go like, I don't know, let's say you walk into your dorm and into your bathroom, and your washing machine isn't working, right? Then you also perform root cause analysis, right? You say, okay, it's not working. Well, you don't just smash the button to turn it back on and nothing happens. And if you then go like, okay, so why could this not be working? Is it not plugged in? Oh, that doesn't seem to be the issue. Is it maybe that the power to the building is cut out, or is the whole street without power, or did the machine break? Do I need to call service, etc. So you try to dig deeper and finding out what really is going on. And then once you found the reason, you need to call the electricity company, or you need to call the mechanic to fix your machine, or you just need to plug that plug back into the socket because it came loose. Now, this needs to be done as early as possible, this root cause analysis, because if you start solving the wrong problem and only discover much later that you're solving the wrong one, you've wasted a lot of resources, obviously, and changing that later on will be quite costly. Right? So that's one of the reasons why root cause analysis is something we do, especially in the early iterations of our cycle in the analysis phase. Okay, so it's time for a little bit of a mini in-class exercise here. So you can think now about a daily problem, and you can do that for yourself, and then try to use root cause analysis to identify the actual root problem behind that. And so one way to do that is to just keep asking why, right? Until you discover the root problem. To give you some more examples, just for inspiration here, let's say you are tasked with designing a louder alarm clock because people have trouble getting up in the morning. You could just build that alarm clock with the louder ringer in it, but you might say, well, what's the root cause here? People aren't getting out of bed in the morning, probably because, you know, they don't have very good quality sleep. So maybe helping them with some kind of device or some kind of whatever to find better sleep, you know, for example, to give them reminders in the evening to wind down and so on, and have a little light exercise, blah, blah, blah. You know, they could improve the quality of sleep, which would then help them get out of bed more easily. They don't need a louder alarm clock if you find the root cause rather than addressing the immediate issue. Or to give you another example, if you look at, you know, people are plugging cables into the wrong sockets, right, on the computer because they get confused, you might say, okay, I can fix that by making the cables very different shape, right? So that the USB cable looks very much different from the whatever HDMI cable, which today they kind of do, but not very much. So that's addressing the problem at hand. But what is the root cause here? People are getting confused with these cables. So why not just have all these cables have the same format and just, you know, deal with the different kinds of things that need to be transmitted in software, which is what USB-C is pretty much doing. Or you might even say, well, do we even need all these different cables? Or can we do with just one single cable that transmits everything between two devices, so we don't have to plug in you know, multiple ones? So there's the chance with these things to take a daily problem and step back and ask yourself, can I go deeper? Can I find the underlying reason why something is a problem? And can I address that underlying problem? So I'll give you a minute to think about this. You already had a bit of time while I was rambling on here about these examples, but think about this for a minute, and then we'll hear some examples. Just raise your hand if you have an example then. All right, so let's get started. If you have an example of something where you can one or maybe more levels deeper than the you know, the problem that you're facing apparently, then raise your hand. See, we've got one already. Shalish, why don't you start, and we'll see if we get more folks. Mm-hmm.
Sure. So one of the problems that I often face, and I'm guessing that a lot of people also face here in Aachen, is just missing the bus and either reaching the bus stop late, or the bus itself getting late and then not knowing where the bus is at that specific exact moment. So, so the most common reason for why people would miss a bus would maybe be because they are reaching the bus stop late or they are running late. But another reason could be that they look at a time and then it turns out that the indicator, the app that was showing when the bus would reach, would say, okay, it's plus 5 minutes late, so you can probably reach it. And then suddenly it somehow catches up to the bus stop, and then the bus comes just before you're able to reach the bus, and you see the bus going ahead of you. And you're like, okay, I missed it. And sometimes if you're going particularly far away or to a distant location, the buses are not as frequent, which means the frequency is pretty low. So either it's one bus in an hour or even lesser. So, yeah, so it could be that reason. And why the bus would be running late, I'm pretty sure it's because of the traffic, or because they think that this specific route has very low occupancy or very low ridership, essentially. So. Mm-hmm.
I like your problem, very much taken right out of the middle of a student life and the pains of daily commute between university locations. Well, one way that I was thinking about as you were saying this is to say you could be asked to, you know, build a better system that announced and tracked bus delays. Mm. And that's certainly a viable task. I mean, we have apps that do that. And in fact, one of our former students Joachim Kurz actually joined the folks that are developing these applications here in Aachen, and works for IVU, or used to work for IVU, and was behind the first designs of the bus tracking app that was available in Aachen. I was very happy to see that. But the root cause, we could say, well, rather than trying to fix the symptom of the bus running late and that people are, need to know about this, why not just, address the traffic patterns in the city and provide the buses with more dedicated lanes so that they don't run late in the first place, right? To reduce these delays. So that would be an example of this root cause analysis, where rather than trying to fix the symptoms, you are getting to the root of it. Okay, thank you. Leslie.
Hello. Yes. Hello. I want to the problem I want to mention is the because now it's in winter in Germany, and so everybody use the heating system. But when using the heating system, the air in the room is getting drier and drier. Now the air is very dry, and we feel not comfortable. And the first reason we can think of is we open the heating system for very long time, so the room getting drier and drier. And then we can start now. Why we open this heating system? Because the weather is very cold, and in the meantime, because the weather is very cold, so we don't open the window. So there's new air. There is no new air. There's humidity air come into the room. So I think the root cause is the the weather is too cold.
I love it. Yeah. So you're saying rather than dealing with all this heating stuff, we should just fix the weather, right?
Okay. Perhaps the root problem is that the people will always close their window and always turn on the heating system. So perhaps the root problem we can face is to add something to the heating system, because we always open the line, so we always have this problem with it. When we turn on these heating systems, then some system which humidity or the humidifier just open at the same time when we open this heating system.
Yeah, I think again, I'm seeing an interesting related example that could work for the root cause analysis quite well. When you say, well, people are in the winter, they're getting dry eyes and all that because the air is so dry from all the heating. So we install so people open their windows to let in fresh air, which of course is good in the first place, but also wastes a lot of energy if they leave a window cracked open the whole day. You could say the root cause is really the fact that the air is too dry and not that it needs to be exchanged. So you could maybe add some humidifier system to it so that people would feel more comfortable in the heated rooms. Yeah. Okay. Thank you, Leslie. We'll take one more. Frederick, go ahead.
Okay. My problem is that food, or lots of food, gets thrown away. And why does it get thrown away? I would say because the people think that the food is bad, mainly, so that it turned bad. And why do they think that? Maybe it doesn't look so pretty anymore. That could be one reason. But also mostly because it might have been in the fridge for a long time. Why has it been there? Well, because they might have bought it at an urge and forgot it and didn't know when the time was ticking. So my root cause would be that people forget the food that they have bought, and that they don't really think about it after consuming the first two, I don't know, carrots of the bunch. So how I would solve that, maybe, because if I try to go deeper, it's basically level of human cognition in a way. So I would maybe just have a logger which knows how long fresh food would last, basically, and you can just say, I just bought some carrots, put them in, and then I would know whether it's good or bad. Even though it doesn't look as pretty, it might be still very well edible.
Yeah, and I'll do you one more on that. That's a good, it's a good domain to do root cause analysis, because you mentioned in a sentence there that people are buying this at an urge. So the real issue is maybe that people tend to buy more food than they can reasonably consume. So if, and supermarkets are going to hate this, but if, you know, in the supermarket, as you're grabbing that big bundle of carrots, you know, a little, you know, your watch tells you, oh, by the way, that's 500 grams of carrots. You usually eat 200 a week. So I think you're probably going to be throwing out, you know, half of these. That would actually address the root cause of the problem, you know, buying the food in the first place and bringing it into your fridge and then having it sit there and go bad. So that's a good example, I think, of showing the kind of thinking, right? We try to address the underlying problem, because in the end, that will actually create a better solution, better for the planet, better for the people, you know, better for their health, whatever the goal here is. All right. Okay, we'll take one more. We got to be quick here, but we will take one more. Ziyong, go ahead.
I just wanted to add to the example of buying the food. It's not usually a thing that you can solve from the consumer side, because if the carrots are only sold in 500-gram packs, what can you do, right? Mm-hmm. So maybe the root cause would go even further than that, and we could say, okay, why are they only selling carrots in such large amounts? And perhaps further on, yeah.
Yeah. Okay, great. Yeah, that's a good example. Yeah, then maybe there's an issue about like how things are being presented at the market, etc., how they're being packaged, etc. Wonderful. Yeah. So you see, we're trying to push you towards asking whether the problem you are called in to solve is really the problem that should be solved, that should get your attention, or whether there is a reason to take a step back, dive a little deeper, and do a root cause analysis to find the right problem to solve, where everybody's better off afterwards. All right, so this idea of stepping back and finding the right problem to solve rather than just going ahead and solving it is part of this thinking like a designer, right? And what I want you to understand is that if you look at the waterfall model, for example, it suggested a very sort of streamlined process in which you had an unstructured problem. You structure it by doing your requirements, and then you basically are following a single path of narrowing down and constraining your solution and implementing it, building it, and making it work, right? You were aiming towards one goal. And that isn't reality. If you're designing software today, you go more through like you could say a breathing cycle, if you want, where what you first do is at the beginning of a project, you get called in and you have to actually do root cause analysis and these kinds of things to even discover the right problem to solve. That means from a single point, you get called in because, you know, hey, you need to build an automatic waste disposal system. You need to build a fridge with an automatic waste disposal system that throws out old food automatically based on its expiration date, right? That could be the task that, you know, Liebherr or somebody or Miele gives you. And then you go in and say, like, is that really the problem? And then you discover there are alternatives to think about this, etc. So you broaden your scope. You look broadly what's going on left and right. You look behind the obvious. And then you define your problem. So you narrow it down and you say, okay, this is really the root problem I want to address. For example, I really want to, you know, address the urge of people buying too much food in the first place. And then you're at this point in the middle here in this model. And then you get into, all right, now we know the problem. Now let's find the right solution to that problem. And that's the engineering mode that you're used to, right? You know, find the right solution means, again, exploring alternatives, looking at different options. What could I do to address the fact that people are buying too much stuff in the supermarket? and then you find one, and then you're broad, right? So you're at the last quarter here of this model, and then you narrow down from that, picking one of these, you narrow down onto that solution and you implement it. So that's why we say it's discovering, defining, developing, and delivering a solution. Discovering the problem, defining the problem, and then developing and delivering the solution is the sort of the real process that's going on. And this whole this thinking has been around for, like I said, since the 80s. We know in HCI that this is an issue and that we need to step away from the waterfall model and need to do more of this iterative thinking. That we need to understand what our users are doing, that we need to prototype, that we need to test, that we need to develop lots of ideas, et cetera, et cetera. I was teaching at Stanford in the early 2000s, and we had wonderful classes there, like the interaction design studio, in which we were really taking students through this cycle, similarly to what we're doing here now. But it was only a few years later that these practices and these methods were being put under a new umbrella called design thinking at Stanford. This is sort of what I'm trying to share here, is just a glimpse of what we today understand with the term design thinking. It's not so much a single sort of timeline process like the waterfall model or even the DIA cycle, but it's more different facets of your work that need to work together. And they are roughly sorted in time order, but it can differentiate. That's why it's not just a single line here. So on the very left side, you see empathize. And what empathize means is that it means to develop empathy with your users, to understand what they really need, what matters to them, what they find important in their work that your software will shape in part, and who they are, right? What the backgrounds of your user base are. If you're designing software, for example, for people working in a factory, driving around, little lorries on the factory floor, you need to understand what these people are doing, what motivates them, how they do their work, etc. So you need to empathize and kind of like try to put yourself into the shoes of these people and really understand them and understand how you can help them. That's the empathize aspect of design thinking. Defining then means understanding, based on these, what matters to these people, etc. What are their actual needs in the current project? Like what are these, lorry drivers, these truck drivers on the shop factory floor? What do they need in the current situation that you are addressing, which maybe is, a problem of developing an app that helps these people do inventory, right? Then the next facet of design thinking is ideation. Ideation means creating lots of ideas and developing a culture of ideas being able to emerge, which also means not to be overly critical to ideas at this stage, which is something we Germans, especially for you international students out there, you've probably learned this. We Germans are really good at criticizing. We love criticizing, right? And so this is where, especially us Germans, we need to kind of like take a step and say, okay, it's okay to have lots of ideas and not all of them are going to be great. Let's take a look at all of these, right? And not judge too early and to exclude things too early. And once you've developed lots of ideas, the way we then filter and cull this out and reduce it again to understanding which way we really want to go among all these options now is to build prototypes that show the idea in action as a rough draft, and then test with that prototype. So we built the prototype in order to use it in a user study, for example, or just to show it to people and get their feedback on it, or to observe them using it and see how they do doing the task with it. So, that logistics tool that you're supposed to develop, you may say, I'm developing a wrist-worn sort of, wearable computing device here that has a large display on the overall of these people that they can glance at, and they see the next, I don't know, delivery scheduled on that display, and they can check off things as they complete their trips. And then you go and you don't build that thing, right? You just make a piece of cardboard and you write something on it, you scribble your interface on it, and you glue that to somebody's overall, and you say like, okay, if that was the interface, would that help you, right? And that's the testing phase then. So prototyping and testing go together in order to understand which of my ideas and which of the aspects of my ideas worked well. Maybe the idea of a wearable device is great, but the idea of putting it on the arm turns out to be a really bad idea because that's not where people on the lower arm here. That's not where people on the left-hand side where they need this arm a lot to do something else. I don't know. And so you decide maybe to put that display somewhere else. So those are the aspects or facets of design thinking. There is a whole bunch of literature out there, but in the end, what we've been teaching with this class is essentially the key ingredients of design thinking, and we've been doing that ever since we've been teaching this class, which I've been doing for a lot of years, 25 maybe. Started with this in the late 90s. So the key point here is really we're going to show you how you engage with users, how you talk to users, how you study what they're doing, how you speak to them, how you show them prototypes and have them use them and get feedback out of that and feed that back into your design cycle to create a better product the next iteration around and a better prototype, and to cut out bad ideas early, big bad ideas, and then sort of slowly converge on a good solution. Let's look at the very start of a project. I would like to share with you the first 3 questions that I think that should always be on your mind when you are faced with a new project that is thrown at you that you're supposed to be working on. And these first 3 questions are at the core of sort of the user-centered design process in a way. So whenever you are designing an interactive system, you ask the following 3 questions first. First, who are the users? Because users can't be everybody, right? It's hard to design for everybody. If you try to design for everybody, which often people try to do, and when I ask people like, okay, so who's this thing for? They are for everybody. It's really hard because you will probably design something which works just okay-ish for a lot of people, and it's really helpful to be specific. If it works for everybody, then you can identify some user base for which it's obviously also going to be of use. And the more specific you get with your user base, the more helpful that information is going to be for you to make design decisions. Second question, the task. What is the actual problem people are trying to solve with your system? What are usage scenarios? And this is where you can use root cause analysis to find the actual question that you want to address. To give you an example, yet another one, if you are working on the problem where people are struggling to sync their contacts between their different devices, the root cause analysis might tell you that they really just want to call people, right? They really just want to call and text folks from every device. And the syncing is not something that they choose to do, right? The syncing is not their actual task. They don't want to spend time syncing contacts. They just want to call people. So that's why, a root cause analysis quickly reveals that you want to get that syncing out of the whole interface. People don't want to think about this. They just want it to work behind the scenes. And maybe have a button to say sync right now because I've just made a change and I don't want to wait for the next update. Make it happen now, but everything else should just be transparent. And then the third thing is becoming more and more important these days. With nowadays interaction is usually designed mobile first. It's weird. I used to only have 2 questions on this slide in the 90s when I started this. It was who are the users and what do they want to do with the system? question 3 didn't exist, because back then, when you designed something for a computer interface, it usually was for a laptop that was sitting on somebody's desk, right? And nowadays, of course, computing is everywhere, and people interact with computing technology everywhere in all kinds of situations. And with your mobile phone, for example, you're interacting with it when you're out and about, when you're waiting at the bus station, when you're, you know, in class or whatever. So the context has become much more important. What is the physical situation people find themselves in, but also what is their attention situation? Can they pay attention to this thing completely? Is it okay to give audio feedback, or would that be disturbing in the situation that they're in? So the whole context of where are they, what's around them. And many projects fail because these very fundamental questions have not been answered. I literally, again, to use an example here from the university, when we went in and talked about, for example, a system to help students file their, you know, I couldn't come to this exam because I was sick kind of reports, we found that folks knew that this system was going to get used by users, by students, but they had forgotten that all these requests would then go to the ZPA. And the ZPA would have to deal with these requests and have to file them around. So they were another part of the user base. We often talk about stakeholders rather than users in this context. Stakeholders means anybody who holds a stake, who this is not the meat kind of stake I'm talking about, right? This means it's anybody who has an interest in this thing and who's going to get touched and influenced by using that software. Not just the primary user who's, for example, the student filing a sickness card, but also the ZPA who needs to process these. And here's the scary thing. All these 3 questions will require asking and talking to people. So, and that can be a bit scary because as engineers, we like to think of very abstract usage scenarios and assume that things will probably be used in a particular way, but that's not always the case. We need to be aware that we don't have a very good understanding of how users actually work, or how they do their task. We're not experts in their task. And, you know, those people driving around trucks on the shop floor of a factory, we don't know how they do their job. And don't make the assumption that you do. You need to go observe and ask to find out who they are, what they want to do with the system you're designing, and in what context they are going to be using it. But these are almost magical questions. If you nail these 3 questions, most of the difficult part of your project is actually done, right? This is the really hard part to get right. And in order to understand who are the users, there are some very basic methods. I'll take another example here. For example, an airline reservation system, right? A system where you can make reservations for flights on airlines. The first degree by which you can classify users is experience, obviously. And it's the most central criterion that we typically use. How much experience do people have? We can stay very general here. We can say, how much experience do people have with doing the task that we want to support? Newbies who have no task knowledge, or first-time users who may know the task, but not our system, typically have no knowledge of the UI and the system we're putting in front of them. And they might have a certain anxiety of doing it. I'll give you an example. You may have somebody who's never flown in their life, right? They've never taken a plane in their life. They've never booked a plane in their life. And so they are faced with, you know, your website for booking flights, right? Your interface. So they don't know what it means to book a flight. They have no idea what connecting flights are, et cetera, that it takes time to go through security and all that. So they have no idea. But you might also have somebody who's been flying a lot. You know, maybe it's a lucky person who always had somebody who booked their flights for them. So they know what it's like to get on a plane, and that planes can be delayed, and that they can be canceled, and that there are security lines, etc. But they don't know the ins and outs of booking the flights online. So they know the task, but they don't know the particular interface. Or maybe they've always done the bookings with a travel office, and now they need to do it on an online website, right? So they know the task, but they don't know the system that you're putting in front of them. So this leads to anxiety of making mistakes, and we want to avoid that, of course. So we need a simple UI. We need one that doesn't overload the features, that doesn't go too Baroque on them. It uses a small and consistent vocabulary with extensive feedback and lots of help available, and documentation and tutorials and so on, videos showing you how to do it to get people through the task, right? So that would be how you would design a flight booking system for people who are casual users, right? Who are newbies and who don't have a lot of knowledge. If you have your average user who knows the task well and knows the UI so-so and tends to forget about functionality between users, you know, maybe the administrator working at an office like our lab, for example, needs to book flights, you know, a few times a year for herself or for other members of the team. And so knows what that means, knows what it entails, but doesn't know the interface in and out, right? And forgets about it between users. So that person might already have slightly different demands on the system, because a super simplistic UI may actually not be helpful. You know, she may have to book flights for 5 people at the same time, and they all need to be on the same flight, right? So that's a different requirement than just booking a ticket for yourself, to give an example. And the simple UI may not support that. But an average user, you know, will still need clear structures, for example, in the menu system or the page system and the links and shortcuts system that a website provides. They'll need consistency will become important so that the system works similarly to other systems that that person already knows. That a help menu, for example, is always in the same place, no matter what app you're using. And a graphical user interface that puts the menu functions in front of you to pick from is, of course, much more helpful to remember what functions are available than a command line system where you type in the commands. Because if you've ever used the command line and then haven't used it for a couple of months and you come back to it, you're like, geez, what was the command to create a directory again? Was it md or make dir, or I don't remember, right? So a graphical user interface is typically quite helpful to most users because it puts the commands in front of them. But you will have to continue to protect these people from making mistakes, right? To book things that they didn't mean to book. And that may still make the interface a little less effective or fast. It's not for maximum performance. It is trying to strike a balance between reasonably performant, but also reasonably safe and helpful. Whereas the simple UI for the newbie is really not for performance, right? It's okay if it takes 5 minutes longer to book the ticket if the person doesn't get lost in the process as a result. And then we have the expert. One day I walked into a travel office, and I actually got a glance because, you know, the travel agent, we were talking about this was years ago, and we were talking about the trip I needed to make. And she said, well, I'm just going to show you what I have here on my screen. And I got a glimpse at this interface that she was using. And I didn't understand a word of what I was seeing, right? Everything is 2-letter abbreviation codes and confusing numbers and weird shorthand notations for everything. And the kinds of commands she was entering, this was literally on a keyboard entering manual commands, were like, you know, bk/2/px/ whatever, you know, SO. And what it would mean is like book 2 passengers with a stopover in, you know, whatever, in Dallas. And it was all very complex, but it was super efficient, right? This was an interface geared towards an expert using it. So she could make the most complex request, like, I need a flight that stops over in Dallas, but on the way back, it takes a different route and it's for this one passenger, but another passenger will join them on part of the trip. She could make all these weird requests with special commands that she all knew in her head because she's doing this all day long, right? And that's an expert user for you. They know the task and the user interface really well. So they want other things. They want speed. They don't want to be held up by the interface. They want efficiency. They want the feedback still to be there, right? You still want to know whether your request went through and whether there were seats available for the request you sent. But you don't want to be inundated with lots of, verbose feedback about, hi, it's so great to see you again. And it looks like you want to book a flight, right? She knows that she's trying to book a flight. It's her damn job all day, right? So shortcuts, right? Creating macros, customizing the interface to her needs, extending it. Maybe if, for example, you need to add train bookings to the flight booking, that needs to just, be able to plug that in and become one single thing. So you can already see with airline reservations from the, fluge.de website or whatever you use for booking flights, which is very much geared towards a novice user who wants to just, be safe and get a flight booked, to this weird interface. You can look up the START system. START is the text-based professional booking system for airplane reservations. And if you want to see some screens of that, it's frightening, right? So that's the experts interface. They're completely different. And here you can see that even with just distinguishing people by experience, we already don't have the right answer for the interface anymore. It really depends on what user we're designing for. There is no single best interface for both the newcomer here and the expert. We need to make a trade-off along that line between newcomer and experts. And we need to decide, and we need to make these hard design decisions, which engineers hate, right? They just want to make everybody happy and put all the functions in there because somebody might need them, but that's not the right way to go. We need to make these tough calls. But experience isn't the only way that you can classify users. We've got background, for example, you might want to understand what educational background they have, what kind of nationality they're from, like are they native speakers, are they not native speakers? Of course, the age also plays a certain role, because as with age, certain cognitive impairments are more likely to be there. And also, priorities shift in what people are interested in. But then there's also computer experience, right? So what kind of experience do people have? And that's a hard thing to figure out, right? Take an architect who's been doing drawings for buildings all his life, but he's never used a computer. He's always done it on pencil and paper. Is he a newcomer or is he an expert? Well, he knows the task really well, right, of drawing, but he doesn't know the computer, right? So you may figure, or it might be, he might be, really good at playing World of Warcraft at home, but he hasn't used a CAD software to do his drawings in his business, right? So you need to figure out particular apps that people have used, how long and how deep they use it. Do they use special functions, or do they just use the run-of-the-mill plain things in there? And then there's the task experience, as I said. Are they new at the task? Have they just joined the architect's office, or are they, or the travel office, or have they been there for 20 years? Another dimension is personality. We often find that in particular jobs and roles, people also tend to have, to pick these jobs because they have a certain personality. For example, you need a different personality if you want to work in a used car sales place to sell used cars than what you need when you are working in a tax tax lawyer's office, right? Or an accountant's office, right? The accountant's office will be down to the numbers and will be happiest maybe with all the numbers and all the data around her, but not so great in human contact and talking to folks, not as extrovert, for example. So introvert extrovert is a well-known personality difference. Most of us computer scientists tend to fall slightly more on the introvert side than the extrovert side, for example. which means if we're designing software for people who are naturally more extrovert in our user base, we have a hard time understanding how these people think and work and what they like. There are other differences there's the Myers-Briggs personality indicator, for example, or MBTI, I think is called, is a good test that you can take to find out, for some of these personality traits, where you lie. Systematic versus spontaneous is another dichotomy, or the aversion to risk or the welcoming of risk to take, or whether you are an early or late adopter of new devices and systems and technology. And these things will shape how people, what kind of interface people need, what kind of system people need to help them. To give you another example, many of us are good at remembering and keeping lots of things in our heads at the same time, right? Because that's an important trait for coding, right? If you're coding, if you're a good coder, you keep very complex structures in your head and you mentally traverse trees and data structures in your head, and you write your code as you do that. Our minds are geared towards this, and we're trained in this professionally also as part of our education. But other people have different skills. A nurse has very high skills, hopefully, in empathy and caring about people and reading people and what they might need or not need. But that's a different skill that we may not have developed as highly. But if you're now writing software for a nurse to use, then you're going to struggle to build the right system that he or she can use, right? Because you're not of the same personality. So, one way to find out about our users is to talk to them. The other is to observe them. And you might say, well, okay, but wait, I don't have a design yet that I can test with users. So how should I observe them? Well, the point is you don't need a design to start observing people. There are lots of designs out there already that people are using and that could be relevant. Let's say you are supposed to design a new machine to issue tickets for a train station. You can just go out and watch people using the current ticket machines that are at the main train station in Aachen Hauptbahnhof. And doing that, you learn a lot, and it's also fun because you will discover that you are far from understanding how other people use this machine. You have a certain way maybe of using it if you know the machine, but you're just one user, and your language skills, your experience, etc., are very different from other users. So you need to observe a random sampling of people using, for example, that ticket machine to understand how this thing is actually getting used in practice. So when you observe users, you want to set yourself a few goals, right? What, for example, how will you analyze the data from your observation? What are you looking for? How will you observe your users, and who will you observe? What kind of users will you take a look at? And what I like to do in projects when we are trying to understand our users, this is the empathize aspect of the design thinking, right? Or the analyze phase of the DIA cycle. We like to triangulate. What I mean by this is you use multiple methods and sources to confirm your observations. Ideally, you observe people and then you interview them and talk to them, for example, to confirm your observations and to see whether you missed something.
Okay, das
because thank you, Apple. Because the observation doesn't let you look into people's heads. You may see people pushing a button repeatedly and annoyed in much annoyance, but you don't know why until you talk to them and ask them, right? So that's why we need both observation and interviews. When you do observations, it's a good idea to run a little pilot, which means you do a small scale observation to debug your observation process, right? Just to find whether you have the right tools with you, whether you may end up needing a microphone to speak into because you can't take notes fast enough, for example, or whether you picked the wrong time of day to do the observations at the ticket machine, for example, because nobody's buying tickets, at 2 p.m. or something. to give you a framework on what kinds of things you might want to look for in an observation, we're going to unroll one that is taken from a book called Interaction Design, written by Jenny Priest and colleagues. It's a good book that's quite elaborate on these non-technical aspects of interface design. So the simple observation framework they're suggesting in there is people, places, and things. Who's using the tech at any time? Where are they using it? And what are they doing with it? Now that's very simple, right? And that is about the users, the context, right? That's the places, and the tasks. What are they doing with it? And you can unroll each of these in more details. For example, you could go down and say, what's the physical space like? How is it laid out? What are the names and relevant details of the people that are involved in the action? What are the actors doing? What are the activities and why are they doing it? What physical objects are present, like furniture, equipment, wall calendars, etc. What are specific individual actions that take place? Is what you're observing part of a special event? This means, like, for example, are you observing the ticket purchasing process? Or are you observing the ticketing process and now somebody discovers that their credit card has expired? That's a special situation, and now you're watching that happen. What is the sequence of events? What happens when? What are the actors are trying to accomplish? What are their goals? This is very much like the 7 stages of action goal that you wonder, like, what are they trying to do in the first place? And is there a mood of the individuals doing the interaction? Or maybe if it's a group, for example, 3 people are lining up to buy tickets together. Are they relaxed and joking and getting along with the system, or are they getting tense or frustrated about it, not agreeing on which button needs to be pushed, etc.? This all sounds very abstract, I know. So I'll show you a video which I love. It's quite old, but it studies something that every year we look at this video and we're like, I can't believe this is still relevant, right? It's a study of projector use, or beamers, as we like to say in German. So it's looking at how video projectors get used in classrooms, meeting rooms, seminar rooms, this kind of thing. Now, you may think that you know everything about a projector and how it's used, but take a close look and listen to this short video that reports on the findings of a group of people who really observed folks using projectors and then analyzed what they found. This is a very deep and carefully done observation on projector usage that I think is quite illuminating, because I think you will learn things about projector use and you will begin to put words to concepts that you hadn't thought about before. And this is the kind of stuff, these are the nuggets, the gold nuggets you can find when you do a careful observation. Now, I'm going to make sure that I share audio here with my video and that I optimize for video clips so that you can see this video hopefully as well as I can see it. This was done in Xerox PARC, by the way, this video. It was a 2-week study. Please pay attention how the real users are being observed while they're using the system, and how the observers empathize with the suffering of the users. And I want you to reflect on, have you noticed these things as well? Would you have drawn the same conclusions? Are these things obvious to see, or do they require some extra thinking from just after seeing this? It's interesting because the video captures the whole social context, even embarrassing situations. And it shows that interface design is a really, really complex task. It takes larger issues into consideration than just one person interacting with technology. There's a social environment, there's other people in the room as you're interacting with the projector, and these guys paid attention to that. So, all right. So what you saw there was clearly a deeper analysis, and I just hope that this gave you an idea of what you can find out when you really closely observe people and try to think about what's going on. And that requires some training, having some models of how we do this. That's why we're going to talk about a few of the methods that you can use, for example, to observe users, but also to interview people. For interviewing, you'll need an interview protocol. You just don't just walk up to a person and start asking them random questions. You have an idea of what you want to ask, and that's in your protocol. And for your initial input, the recommendation is not to immediately throw your design prototype idea at people and ask them about feedback about that, but first, listen rather than tell them. So use the interview to understand and learn about the task. It doesn't have to involve your system at all. If you're designing, for example, a new app to control projectors better, you would start by doing something like what these people did, just observing the state of the art, what's going on today. Just like with the observation, a pilot interview is good to interview one student in your group or outside your group, just to debug your process. You don't expect very helpful results from this, but you use it to debug your process. It's always good to have one person doing the interview and another person, a separate observer, to watch that pilot interview and observe any pitfalls and make note of these so that the interviewer can pay attention to the interview. How do you ask questions? Well, clear, simple, focused questions. For example, it's very tempting to ask, how do you like the user interface? But that's way too general. You don't want to do that because it will not give you very useful feedback in response. Also, and this may be surprising, but users are going to lie. And maybe that's a bit drastic to say, but they're not always going to answer truthfully. And this is not because they want to deceive you. There's a couple of reasons. One reason is that they may not know. If you ask somebody, so how many hours per week are you using Facebook? Are you on Facebook? They may not know. They may just estimate it and make a bad estimate. Or they may have an idea, but they think that it's not appropriate. So they may give you a different number, right? So you have to formulate your questions carefully and sometimes ask about things in a more indirect way. Finally, you got to be really careful about leading questions. For example, you may want to find out if you need to add audio playback to an ebook reader. Now, if you ask, do you want audio playback in an ebook reader? That's a leading question, and that's bad, right? You don't want to ask that because then everybody's going to be like, oh, yeah, sure, why not, right? A better question would be, when you're reading an ebook, are you listening to audio while you're doing that? That's a little better, right? That gives them a chance to report on their own activity rather than these like, what if, would you like to have this feature kind of questions. So you don't want to bias the user with these kind of leading questions. It's also important to ask your questions in a way that they are useful for you to use in your evaluation. So asking people, are you a novice or an intermediate or an expert user of Microsoft Word is not helpful because everybody has their own understanding of whether they think they're an expert or novice. So you rather want to ask, are you using particular features, or how many letters do you write? How often do you open up Word? A couple times a day, a couple times a week, a couple times a month. Those are kind of good questions to ask to get an idea of how deeply people are involved with some software. What do you get out of an interview? Well, you get a user profile, right? And this will also hopefully also give you a profile of the task that people are doing with that. And if there is already a system involved, you will hopefully be able to identify current problems with it, ideas for improving it. And in our case, when we run these interviews in starting your projects, you will hopefully get an idea of how the task that you are doing or that you want to support with your system, how that task is carried out today. Okay, so you've done your observations and interviews, you've watched people, you've talked to them, figured out how the task and context and what their background is. Now, what do we do with this? How do we aggregate this information? For user information, for information about users, there is an interesting, easy way to do that. And that way is called personas. A persona is a precise description of a user, but that user doesn't exist. Now that may seem weird to you, but the point is that it's a hypothetical user, but the description of that hypothetical one user is based on the data that you collected in your observations and interviews. So it stands in for a real user. Why? Well, there's all kinds of issues, right? You don't want to report exactly on all the things you heard about one user. You may not be able to share that information widely because of privacy issues, etc. Also, you want to have a representative for a set of users in your design process. So you're taking things you observed and you saw with individual users, and you collect these and you build your hypothetical user from these observations. The great thing about a persona is it is not elastic. What do I mean by this? Well, if you just talk about a generic user profile, our average user is, you know, a business person, and they're like whatever in their 30s and their 40s, and they do this and this, and they travel a lot. This is all great, but it's not nailing it down. If you give that person a name, you call him Bob and you say exactly what is his family relation, like does he have a wife and kids at home, and you say exactly how many hours does he work, what are his tasks, etc. You make it concrete, and that representative, that concrete representative, is then no longer elastic. If you've already said that he has a wife and kids at home, you cannot in the next sentence or like 2 weeks later say, oh, and I'm sure he often enjoys working overtime and on weekends or whatever. That then starts to sort of contradict the profile you've already given that person. Here's an example of one of those personas, also taken from Jenny Priest's book, and I'm going to zoom in on that. And this is for a persona for a teenage girl who, and you can see here, she's called Jenny. She's got a name. We've taken some random stock photography to give her a face. And she's 15, female, ongoing, private education, ambitious, comfortable using tech to communicate. Her motivation is to keep in touch with her network of friends. And she wants to, she wants some street credibility and know about the latest fashion trends and keep up with her peers. And there are some frustrations that she knows. There's like sad people trying to be friends on Facebook, or having to be in bed at 11 p.m. or being swamped in friend updates, or missing important status updates from her friends, right? And so this gives, and this is then spelled out in a little more detail here with pictures of stuff, items that she knows and that she enjoys and stuff and things like that. So this gives that person a face. And design teams often take these personas and make them part of the design team in a fictional way, right? They say, well, would Ginny like to have this feature? Would that be useful for her? Remember, we talked about what her preferences are, etc. So some people go as far as creating life-size cardboards of these personas and putting them up in their workspace of the design team, just to be reminded that there's a real face, even though it's hypothetical, but a real single person that they've identified, that they are designing for, right? To stay away from that danger of the anonymous user. You may have to develop more than one persona, especially if you've got multiple stakeholders. So for example, when we did the work with the ZPA and the students, we had a persona for the students, and we also had a persona for the ZPA. Because these are completely different user bases that need different things from the workflow we were designing. Okay, so that's how you can wrap up your understanding, especially about the person you're designing for. Now, next up, we move into the design phase of the DIA cycle, right? We've done some analysis. We've understood, hopefully, user context and task. And now we need a first technique to design. And the first task is brainstorming. It's one way to do initial design. The goal for brainstorming is to collect as many ideas on a given topic as possible. This is a high energy task. So you need to relax, you need to have fun. it's a good idea to invite people who you know are good brainstormers from experience. If you've worked with them for a while, you will know. And brainstorming doesn't judge, right? You defer judgment. You don't criticize or argue about ideas being brought forward. Instead, you leapfrog on each other's ideas. If one person makes a crazy suggestion, you don't say that's a crazy suggestion. You take it, you think about it, and it may inspire you to think about another idea that may be just as crazy or even crazier, or maybe not quite as crazy. And these are all good. Because in brainstorming, we go for quantity, not quality. So including crazy ideas is perfectly fine. When I say quantity, I mean that you actually can put yourself a goal to create a certain number of ideas for your project solution. Like 100, you want 100 ideas in your brainstorming. That sounds like a lot, right? But if you really learn to quickly, be on your toes and just throw out all the ideas that go through your head, then you can get to those numbers. How brainstorming usually works, if we're not in a Corona situation, is that you're all in a room, everybody is yelling out ideas, and one person is madly scribbling on a whiteboard, the scribe, and he's collecting them for everybody, right? That's the idea for this. This needs to be limited. This can take like 5 or 10 minutes, maybe. You don't do this for an hour, you will die, right? This is a high energy task, as I said, so it's not something you can continue to keep up the energy for a long time. To help you do a brainstorming, it helps to think about a couple of habits. For example, positive or negative habits, or physical gadgets, that how the habits can be linked to these particular gadgets. And since you want to stick to a particular domain, like diet or exercise, drinking, smoking, hygiene, whatever. And in these kinds of things, it helps you to answer a couple of questions. So if you're struggling with just ideas for how your system looks, ask yourself instead, who could be possible users? So for example, part of your brainstorming could be about, let's think about all the kinds of users who will be using our system. And then you can think about normal personas or very crazy ones that you think about. And then you can brainstorm on tasks, like what kind of tasks do we want to support with our system? And you can think about tasks within that domain that you've identified that you want to be in. And then you can identify, locations where the system could be used. And again, you can think about everyday ones, or you can think about really crazy ones. And I want to actually do this one as an in-class exercise. We won't be able to do everything as an in-class exercise here today, but this one I think we should be doing. So Ollie has prepared a couple of rooms for you guys. And Ollie, do you want to just quickly pitch in here and explain how this works?
Yeah, sure. So I created a Miro board for you. I just posted the link into the chat, and every one of you can now hopefully join the Miro board, and there you will find 50 different frames. If you, different frames, and on these frames you should do the brainstorming. I will assign you to breakout rooms. Those breakout rooms are numbered, and then go to the frame with the number of your breakout room. And there you do the brainstorming on how to motivate people to clean their rooms. We will give you 5 minutes for that. And you do this by, again, one of you should be the scribe, so the one who creates the post-its. The other ones should shout out their ideas. And the scribe should create the post-its with the toolbar on the left. There you see a post-it icon, which is there for, writing everything down. And
okay. Das habe ich online zur Hesiri. Wo ist
this time it's exceptionally me. And I think that's it. You can also find these slides on the Miro board on top. I see many people there, and honestly, I hope that this will work out with so many participants. We never tried it out with Miro before, but I think we can start with that. So I will assign you now.
And
are there any questions?
Yeah, and the topic that we want to do for this is just a little exercise, right? How to motivate people to clean their rooms is sort of the the topic you are trying to address, right? How do you motivate people to clean their rooms? And that's what we want you guys to explore in these small breakout groups. We make them small so that you can actually talk over each other. Although I know Zoom isn't perfect for this, but with a few people in each group, I hope that you guys are going to be able to do that. Yeehaw! Okay, so that was fun. The joys of online collaboration. I hope you guys were able to occasionally put down an idea or two on the board. And I know we're struggling, right, with the online format. This is one of the things that doesn't really work that well in an online format. So sorry about that. But I'll continue sharing my slides in a second. And for now, what I see on the Miro board is we're beginning to see a bunch of things. Give them a lot of presents to make more chaos. That sounds like a fun idea. A talking vacuum, paying them to clean the room, give them regular reminders, or develop something, smart rooms that clean themselves automatically. There is somebody who's going all the way into the root cause analysis, right? Why would I even have to clean my room? Reward them with sweets. Yep, I just watched the episode from Big Bang Theory where Sheldon rewards Penny with sweets all the time. So that's a good one. Have a vacuum which takes everything out to the trash each day at a certain time. I love that vacuum. I'll buy one of those immediately. Okay, so we can see there's lots of suggestions here that are beginning to fill up in the board. So great. But this is exactly the kind of stuff that we want to see, right? Lots of ideas. Not all of them are good ones. Some are funny ones. Some are crazy ones. That's okay, because what that does is it kind of like unlocks certain barriers, right, in your thinking. If everybody is ready to say whatever they want, you don't hold back, and sometimes that lets you discover this weird out of the box idea that you actually need to create a great new revolutionary product. Okay, I'll continue sharing my my slides then to move on. Hold on. Share this desktop. Boop. Okay. So once we've done that, we need to somehow structure that, right? And structuring what we collected is done with something that's called concept maps. And concept maps are a technique that's very old. It's been around since the Middle Ages. What they basically are is like in this example here, this is a concept map around large interactive public displays. It has the topic of the collection in the middle, and then it has branches going off from there, highlighting individual subtopics. And from these subtopics, we've got more branches going out all the way to the individual items. So in a way, you could say, mathematically speaking, it's a tree, right, with the root at the center. And what we do with the concept map is we take our various nodes, we cluster them into related areas, which could be done on Miro. And it then helps you to take these ideas, move them into related sub-areas, give these sub-areas a name. For example, in our motivating people to clean their rooms, one sub-area that we could maybe see would be something like, automatic vacuums or something, right? Or another one could be rewards. And then there's the idea with sweets and other stuff and paying the money and so on that goes into that area. So we structure our ideas by identifying related ones, putting them in subcategories and moving these sticky notes together in this case. And that helps sort of give this space a shape. Concept maps are also sometimes called mind maps. You may have heard the term mind maps. That term is unfortunately copyrighted by some guy in the 70s. It got copyrighted. So we tend to talk about concept maps instead. It's the same thing. They have a few advantages over just making a hierarchical bullet list. The first advantage is that they are visual, they are graphical. So each concept map will have a fairly unique shape and look to it that is different from anything else you've ever seen and your brain has ever seen. So that helps you to remember things in a concept map. In fact, this goes so far that sometimes when people structure what they learned in a class or something like this, or from a book, when they structure that as a concept map, they will remember, oh, there was something up there in that top left corner of my map. And so this visual structure helps use both sides of the brain, both halves of your brain, both the analytical side and the sort of more visual side, to remember things well. So make concept maps a universal tool for structuring knowledge in your student life. It's a really great tool. And concept maps will always look a little bit more unique and stand out. And they're more fun to look at than, you know, just the 150th list of bullet points. The other thing that concept maps can do is you can add graphical icons to it. As you can see in this one here, somebody with decent drawing skills put some little notes and things next to some of these sub areas, right? For example, all the stuff that had to do with information had a little, you know, light bulb attached to its sub area, right? Or, you know, things that had to do with music were marked with a little microphone and some notes, but down there at the lower back, and so on and so on. So these icons may seem like, you know, needless decoration, but they make the concept map super unique, right? They really make it easy. Months later, when you go back, you will immediately remember, oh, there was a whole section on information because there's that light bulb. So again, it helps structure and remember things and communicate things well. So the next exercise we would try to do here, and this is something that, let me take a look. I think we're going to skip that. We're going to do that in the lab because it will take a little time, and you'll be able to do that in a lab, I think, more effectively. And I have another exercise that I would like to do instead with you guys. You know, so the next exercise would be to take the ideas you collected about, you know, these helping people to clean up their rooms and turn them into a little map. Now, the next format after the concept map is the storyboard. And the storyboard is a structure that helps you structure, is a format that helps you structure the question of what people want to do with the system. We now have lots of, you know, you could say project titles, right? Project ideas, you know, little nuggets of, you know, the self-cleaning robot or the reward system when people do clean up their room and so on. And so now we want to tell a story around, like a usage scenario around that concept. So a storyboard captures a couple things. It captures what people are doing with the system in a sequence of single images. It's like a visual outline of a film or a comic, really. It visually represents a script and illustrates the interaction that we are imagining. Now, why do we do this? We want to visually describe the task, showing the environment and the user and the computer. Or maybe we want to show a user interface in detail as a series of rough sketches of the screen, but we want to include sort of the hand or the finger of the user or the mouse pointer where the user is clicking or touching, etc. A storyboard helps you, first of all, tell others what you are imagining the interaction could be like. If anybody has ever watched these making of videos, especially of, like, you know, animated movies, like Pixar movies and stuff, sometimes there's a clip in there where they show how the design team created storyboards of the film long before the actual film was actually shot or produced, right? And then they make these comic drawings of the story in, like, very simple, quick snapshots, and then they tell the story of the film using these visuals as backup. And that's kind of, you know, these guys are experts and pros in doing this, but this is kind of in a way what we want to do with the storyboard too. We want to tell the story about our system using the storyboard as a hook. It also gives a great at a glance overview of the interaction. So a good storyboard is one that you can give to somebody else, even without comments, and they can look at it, read through the comic if you like, read the captions you provide, and get an understanding of what the system's interaction is going to be like. So this is a great helper to develop usage scenarios, tasks, tools, interaction details in your setup. When do we create an actual storyboard? Well, we have developed maybe an idea. We've described a task in some writing maybe, and then we create a storyboard. So we tell that little story of how the interaction could play out. And we take it back to our users or our design colleagues, and we ask the users, did we get the story right? So for example, you may be observing people, to put it very simple, without any design of your own. You observe people at a ticket machine at the train station. From your observations, you draw just a normal interaction with the ticket machine as a storyboard. You tell what's happening in each stage. And then you take that back to users of the ticket machine. You say, is that how you typically use the machine? Right? That shows that you actually understood the task. And for that, you haven't invented any new interactions at all yet. You've just documented the state of how things are right now. And then in a second storyboard, for example, you could say, I'm imagining, I don't know, a voice assistant helping you through the interaction. And here's my storyboard, how the interaction would play out with a voice assistant. And then you can take that to your users too and say, hey, if that voice assistant was there, would that help you navigate this interface more effectively? Would that work? So I know, again, this sounds abstract, so I'm going to show you an example. Back in the early 2000s, I was at Stanford. I was teaching this class to students there. And one of the things we told students to do was to come up with a technology that would help people, in their daily lives, very, very broadly. And one team came up with the idea of recognition glasses. Glasses that would recognize other people and give me details about these people as I saw them through these AR glasses, right? This was their idea, and how they imagined these recognition glasses to help people, they expressed in a storyboard. So they drew two comics, one comic without the recognition glasses and one comic with recognition glasses. Let me show you this storyboard and just a little glimpse here. So the top one is the storyboard without recognition glasses. Bob is walking somewhere down the street. Bob is the guy on the right-hand side. And he runs into another guy. And this other guy says, oh, hi, Bob. But the problem is Bob can't remember faces. So he's stuttering around and he's like, how is your wife? And this other guy, he doesn't even have a wife, right? He doesn't remember that this other guy is actually Tim. And Tim is upset because he thinks Bob is a moron. He thinks Tim has a wife, even though he doesn't. So embarrassing moment for Bob, right? Now, in the bottom, we see what happens if Bob has recognition glasses. So Bob runs into Tim. Tim says, hi, Bob. And Bob's glasses immediately show that he's talking to Tim Brown. And so Bob remembers that Tim has a startup. Remember, this was in the early 2000s, so everybody was still excited about online startups. And Bob remembers Tim Brown's startup called Brown.com. And he's like, hey, Tim, how's your startup doing? And then, of course, Tim is happy that Bob remembers him and his startup. And then, Tim says, oh, it's going great. Want to catch a coffee maybe sometime or something. So things go well, right? That's what this is expressing. As you saw from this there's a couple of things I want you to take away from this. First thing is, within just a minute or so, I was able to tell you a story and to engage you. Storytelling is a super powerful tool, right? I was able to engage you in a story that showed how these recognition glasses would help our hypothetical Bob to navigate an awkward social situation better. And I did this with 2 panels, right? One panel without the technology, one series of panels without the technology at the top, one series of panels with the technology at the bottom. And within these few minutes, you actually got the basic idea of what I'm imagining these recognition glasses are able to do. I haven't talked about how they work, what they look like in detail. It's just, you know, some dorky glasses in this drawing. The other thing you're probably thinking is, oh man, I could never draw this. This is so well drawn. I can't draw like, you know, I can't draw for shit. Okay, let's fix that. I'm going to show you how you can actually draw people. And this is going to be the last exercise for today that we're going to do. And for this, I'm going to try sharing my my screen here in Zoom. Let me do that real quick.
So start with drawing a star, or sorry, circle, and then a star. Or you can draw the star first and then the circle. Some people put pyramids on these figures. So just draw a bunch of starmen. Circle, star, circle, star, circle, star. Draw little ones and big ones. Now, the irony of this is that we're thinking about computers that we're designing. Keep drawing. I'm going to talk over your drawing. Make little ones and big ones. If you wanted to fill a diagram of your system with people and you're doing it on a computer, you might just draw one person and then copy it and then paste, 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 paste. Now, the disadvantage of that is everybody looks the same. There's only one kind of user in your system or one kind of person. And what you have in front of you is a whole variety of very different people. We haven't intentionally done that, but by accident, you've made mistakes and you've made them different. You've intentionally pushed them to be sad or happy or exulting. So try pushing yourself to make big differences. Now, if you really care about where he's turning, you can put a nose on him like that. Or you can turn and put eyes on him. These are sort of cartoon tricks. And you can make him into a half smiley face. So if you have a big face, big circle, you can put some features on it. There's another way to do it. Just draw a little cross. And you can provide some point of view. Also, if you want him to be, or her, now these all look like men, don't they? They could be women. We can put a mini skirt on them, on her. And the tank top, and dress them. I guess I'm interested in just what you can do with the circle and 4 limbs. You can make them exalting. You can amputate one limb. And what are these guys doing? You can have them raise one hand and let the others go down. You could do a whole set of acrobatic starmen. I can't do that. You draw an upside down starman. Oh, that's a nice one.
Okay, I'm gonna stop the video here, and this is, I think, a good example of how we can draw, and we're going to continue doing the drawing exercises in the lab, and we're going to talk more about storyboards next week. So I want to wrap this up by saying that what we've seen today are the very first few, so to say, parts of doing designing interactive systems. We've talked about DIA, the DIA cycle. We've talked about, you know, this opening of possibilities and narrowing again that happens over the course of this design and develop process. And remember that you know, developers are good at solving problems, and designers are good at finding problems. We talked about the 3 basic questions of who are the users, what do they want to do with the system, and what's the context. And we've seen an example of how to brainstorm and how to create concept maps to structure that. And storyboards will be sort of the next thing that we go into a little bit more. You've seen an example here, and the drawing exercises will continue next time to give you a bit of more tools of the trade. We can do that both in the lab, and also you'll have an assignment that will also let you practice these skills a little bit. With that, for this week, I would like to wrap up. Thank you everybody for joining us, and hope to see you again in the next class. Thank you and bye.
This content was provided by RWTH Aachen University.